Alrighty friends, welcome back to our last video for this week. Just a reminder again that on Thursday we are likely to have an atmospheric river event that may indeed be significant. So we may be holding class on Zoom that day. So please keep an eye on your announcements and I will keep us updated on the status of that. Okay? Okay. So now I want to talk about the negative impacts of tropical cyclones and generally the most destructive aspect and impacts. And then we'll shift from tropical cyclones into what's called ENSO, so the El Nino Southern Oscillation, and that will finish up the atmosphere. I could talk about the atmosphere for ages, and we know that, but we got to continue on. So if you do find yourself really enjoying this kind of content, then you are more than welcome to take my weather class at SF State if you happen to ever transfer there. I would be happy to have you. Anywho, so the most impactful part of a tropical cyclone is not necessarily the rain or the wind, though the wind does have something to do with it. It's actually the resultant floods that happen from something that we call storm surge. So because we have these low-level winds at the surface, converging winds, right, and really low pressure, makes the ocean water pile up near the center of the hurricane, basically. So it literally looks like a little lump underneath the cyclone. And if the cyclones are in deeper water, then the water will just kind of churn about and like go in further into the ocean. Like, it's not going to have many impacts there. However, the closer that these tropical cyclones get to shore, the more interaction that they have with the continental shelf, for example. And so with that, then the flooding can be really concerning here. Because as I said before, flooding is the #1 meteorological killer, and so water is much stronger than any human. So the tropical cyclone basically brings the water with it. And in this particular schematic in the bottom right, the impacts that would have the greater storm surge impacts would actually, in this case, be on the top side of this storm. More water would be piled up here because you have not only the storm is moving this way, but you also have the winds on the top side of the eye are flowing more into the land, whereas on the bottom side here the wind is flowing away from land. So the less storm surge impacts would be felt here, at least initially, during initial landfall. We saw this very clearly this past year with Hurricane Ian as it made landfall in Florida. And the problem was it hit just south of Tampa Bay. And Tampa Bay, you can think of like the California Bay Area. Like, it's this huge estuary. And the winds were so strong when Ian made landfall, going the opposite direction, that with the winds kind of going away from land out into the ocean, the whole Tampa Bay, all of the water was taken out of it and back into the ocean. And it did come back, but like the Tampa Bay is, like I said, it's pretty much like the Bay Area here in California, so it's relatively. It's just as deep, basically, as the Bay Area here. So it'd be like if you woke up one morning and looked out and the bay was empty. That's exactly what it looked like. I'll try to remember to find some video of that to show us together. Excuse me. So there's so many storms that we could talk about, and honestly, I could just continue talking about tropical cyclones just for ages and ages and ages, but we got to cut things short a little bit. So this is not an all-inclusive list, but these are some notable storms that have occurred in the last several years, going all the way back to Katrina. And then I have a couple other ones here at the very bottom. Almost all of these had some serious impacts in the United States, except for, some of these like the Philippines and Myanmar and Japan. But the big thing that I kind of want to point out from this is the fact that if you compare the number of deaths for occurrences in the United States versus the deaths in other countries, I mean, this was 2013. Her Typhoon Haiyan or Typhoon Yolanda happened in 2013, and over 7,000 people died. And that happened in the Philippines. But relatively low monetary impacts, which is kind of fascinating there, right? So the thing to think about is the fact that the infrastructure in these other areas is just simply not there. We have greater infrastructure here in the United States, even though it's not perfect, of course, but because of that, then few folks tend to die around here, and we also warn people ahead of time. So, just wanted to kind of point some of these out. So Hurricane Patricia, this was the strongest recorded hurricane with over 190 mile per hour sustained winds. Let's see, Hurricane Ian, kind of talked about that one already with Florida. Hurricane Ida and Hurricanes Ida and Laura hit Louisiana, the state of Louisiana, and basically hit the same exact location in Lake Charles, which is pretty scary. Hurricane Dorian had, over $5 billion worth of damage. But what's fascinating with Dorian is it stalled for 2 days over the Bahamas. 2 full days of Category 5, 155, 160 mile per hour winds just straight up sat over the Grand Bahama for 2 freaking days. It's so crazy to me. And what's really horrifying is how it says hundreds missing here. And this is just absolutely devastating. But the Bahamas are to Haiti as the United States is to Hispanic nations, meaning that there's a lot of Haitian undocumented folks that seek refuge in the Bahamas. And when they're undocumented, obviously when big events like this happen, then there's no record of this person ever even being there, right? Which is really horrifying. And the Bahamian government basically burned villages to the ground from the destruction just to kind of cover it up and get rid of them. So that's horrifying. Yay. And yeah, like I said, I could go on for ages and ages about different storms here, but just to kind of point out some other ones, we got Katrina down here. So Katrina hit Louisiana, and a big thing here, right? So about 1,800 people died, but they died several days after the storm made landfall. And I also need to point out here that Hurricane Katrina was a Category 3 hurricane when it made landfall. It was not a Category 5. It did get up to a Category 5, but it weakened relatively significantly before it made landfall in New Orleans. So that's a really big common, it's like nails on the chalkboard for me. It's just like, it irks me the wrong way when that is not properly said. So just had to put that out there. So yeah, maybe you've experienced a tropical cyclone before. Maybe you haven't. If not, you know, I probably wouldn't go out of my way to go experience one by any stretch, but they are absolutely crazy things to look at from afar. So I just wanted to show some pictures here of some of the destruction and devastation that have occurred from tropical cyclones. So these 2 images here are in Houston, for flooding in Houston. This is the city of Panama City in Florida after Hurricane Michael. And this is also Hurricane Michael. The storm moved so freaking fast that by the time it made landfall, it didn't actually fill in. The eye didn't fill in with clouds. So if people were outside, well, they shouldn't have been outside, but if they were coming out, kind of emerging a little bit from after the eye wall had passed, so these are like some of the very only images of a human view from inside an eye where the skies are still clear. So it's pretty freaking wild, I would say. And it's also very unadvised to do this. Very dangerous to do that. So don't do it. Again, if you want to learn more about tropical cyclones, take my weather class. We talk at length about tropical cyclones. It's super fun. Okay. So one last wind system that I want to finish up talking about here is El Nino and La Nina. And perhaps you've heard of these before, especially if you speak Spanish. I certainly hope you have. But El Nino basically means that there's anomalous warm waters in the central equatorial Pacific. And these warmer waters are driven by a change in wind patterns. Wind moves water pretty dang efficiently. So weaker winds mean less water movement. Think of it like if you have a cup of coffee or a cup of tea and maybe you put some creamer in it or some milk. And if you were to blow on the top of it to make things kind of move around a little bit, then the harder you blow, the more intense the circulation that you would see. So same idea, but just applied to a much larger scale. What's really wild is these shifts in sea surface temperatures also shifts weather patterns with implications all over the world. And we'll look at kind of some implications here in the United States in just a sec. Whereas La Nina is anomalous colder waters in the central equatorial Pacific region. So this would be looking at normal conditions, right? If we, this is looking at pressure. So this is looking at the the continent of South America. And we have this region of high pressure sitting off of Peru and Chile. So with this overall movement, we would see relatively cool waters here at the surface. So this deep nutrient-rich water replaces any of the water that's being pushed away from the wind movement. And this is really, really great for local fishermen and local ecosystems. So if you bring nutrients into a space, then you're going to have plankton that are like, oh my God, I love this, nom, 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 nom. And then little fish are going to be like, oh my God, plankton, yum. And then big fish are going to be like, oh my God, little fish, yum. And it's like a whole stepping process, right? And so if you have this going on, then fishermen are like, oh look, fish. It's a whole thing. But if we don't have these cold, nutrient-rich waters coming up, then you basically choke out that system and you take away the mechanism in which starting the domino, right? The domino effect of plankton to fish to human. So that's what we can see in this particular image here, right? So this top panel is normal conditions and the bottom panel is El Nino conditions. So basically, notice how the trade winds are much weaker. The arrows are smaller, meaning that the winds are not moving as fast. So if we're not moving as fast, then we're keeping this warm water near the surface in this area. And there's also another circulation going on here. This is called the Walker circulation, similar to like the Hadley cell, Ferrous cell, polar cell, etc. But it's just like the circulation across the equatorial Pacific. And this is not great for local fishermen, right? So we don't have that initial domino to kind of set things off into motion. What's really fascinating as well is with this oscillation, it's not necessarily consistent or constant, but generally has this 3 to 7 year cycle. This is looking all the way up until about 2016-ish. And just some things to point out is that El Nino tends to have a stronger signal than La Nina. Just looking like we have several El Nino events that nearly get to this 3-level index, whereas La Nina doesn't even get close to touching it. Last thing I want to consider here are impacts to weather. So the Bay Area in particular of California is really, really in the middle in terms of how we're impacted for El Nino or La Nina. See, Bay Area right here. So we are literally right in the middle. It drives me nuts when broadcast meteorologists talk about being El Nino, and that's why we're going to get all this rain. Drives me nuts. But the big thing here for La Nina is that a strong La Nina makes for a more active Atlantic hurricane season, which is really, really quite fascinating. And then I just wanted to end with showing sea surface temperatures for the equatorial Pacific. And if you observe this, which phase do you think that we are in? And if you said La Nina, you would be correct. We are actually, though, transitioning into an El Nino phase. So we'll recap all of that when we come back together as a class. If anything was confusing, I will address it then. All right. Thanks again so much for watching. Appreciate you. Have a good day.